VLSos here. This is a video lesson on radians. Radians are a way of measuring angles and arcs, much like degrees, but they are different size. Let me show you where a radian comes from. I have a circle, and I can draw a radius of this circle. It's not important what the measure of the radius is because what I'm going to show works with any size circle. We can call the measure of the radius r. I'm going to use a piece of string. I'm going to use the string in order to pick up and move the length of the radius. I've colored the length of the radius red, and what I'm going to do with this length is I'm going to set one endpoint on the circle that is at the end of this radius, and I'm going to wrap that radius length around the circle and make a note of where the other endpoint of this length lies on the circle. I created an arc whose length is the same as the radius of the circle by taking that radius and wrapping it around so I knew how far around the circle one radius would wrap. I can use the notation of a tick mark to symbolically show that these distances are the same. The length of this arc is also r, one radius in length, and it creates a point on the circle that I can connect to make another radius of the circle with the same measure. Now when I've done this, I've also created an angle. The sides of the angle are these two radius lengths, and the angle is open just enough so that the arc that it intercepts is one radius in length. The measure of this angle, we could label it as theta, and the measure of an angle theta created this way is what we define as 1 radian. So to be clear, the measure of theta in this diagram that was created by wrapping the radius one length around the circle is what defines the measure of 1 radian. Radian measure arcs and angles. The word itself, radian, contains the root radius because a radian is defined according to this geometry of the radius of a circle. We know from geometry that the number of times a radius wraps a semicircle is equal to this special number pi. From geometry, we defined pi in a similar manner. If we took the measure of 1 radius and we began wrapping the circle with those lengths, we would make it approximately 3.14159 radius lengths around half of a circle. We define the number of radius lengths that wrap a semicircle as this special number pi. So if a radian measure is defined as the angle opening of 1 radius, then the number of radians in a half a circle is equal to pi. There are pi radians of angle measure in a semicircle. And a semicircle is another name for a half of a circle, equivalent to 180 degrees. So a full circle, all the way around, would wrap 2 pi radiuses, lengths. So we could say 2 pi radians is the angle measure in a full circle. So we can convert degree measures to radian measures. And our tool for converting is a proportion. There are many ways to set up a proportion that would work to convert radians and degrees. The one that I'm going to put here is a ratio of degrees to a full circle will compare with the radian measure to a full circle in radians. For example, we could ask how many radians is equivalent to 30 degrees. We could set it up many different ways, but if we set up the proportion in this way, then it's the degree measure that we know, 30 degrees, compares with a full circle in degrees, just as the radian measure that we're trying to find out compares with a full circle in radians of 2 pi. This is an equation with one unknown r, the amount of radians that we're trying to find. To get r by itself, I'm going to multiply both sides by 2 pi. So it cancels out here, leaving r by itself on the right. 2 times 30 is 60. So in the numerator, 2 pi times 30 degrees is 60 pi. Still being divided by 360. We can reduce. There are 6 60s in 360, so I can reduce this fraction to pi over 6. This is approximately, if you use the approximation 3.142, which is pi rounded to the nearest thousandth, then we can approximate pi over 6 as 0.524. This is a radian measure. It's a measure of an angle opening. It's equivalent to 30 degrees. 0.524 radians is approximately equal to 30 degrees. And we know that this angle measure is in radians because there's no degree symbol with it to say that it's in degrees. If you have an angle measure and there is not a degree symbol, then you can assume it's in radians. And because there's now more than one way to measure an angle, we can't be lazy. If we write down an angle measure of 30 degrees, we need the degree symbol to be a part of the number, because if we're working with radians, then an angle measure of just 30 without the degree symbol will imply an angle measure of 30 radians. There are now 3 familiar ways, once we work with radians a bit, to measure angles and arcs: degrees, radians, and revolutions. We can make a quick table of equivalent measures. 360 degrees is equal to 2 pi radians, or 1 revolution. A half a circle or a semicircle is 180 degrees. That's equivalent to pi radians, which is 1/2 of a revolution. Another common angle in degrees is 90. That's equivalent to pi over 2 radians, which is 1/4 of a revolution. And for the sake of remembering that we can measure angles that are greater than a full circle 2 revolutions, it's 4 pi radians, or 720 degrees. These are just a few common conversions of 3 ways that we can measure angles.